This very first problem deals with unit rate and being able to compare unit rate. They tell you that Ed is a farmer who charges $3.75 for 5 pounds of cabbage. So you're going to need to know his unit rate. His unit rate can be found by taking $3.75 and dividing it by 5. You should use your calculator for this. That gives you 75 cents per pound. That's the unit rate. So I put that up top just so we'll be able to refer to it. Now we need to compare these other farmers. We need to compare them to Ed, but we still need their unit rate. So 50 cents per half pound, so you're going to take 50 cents and divide it by a half of a pound, which as a decimal is 0.5. So this is 1/2 divided by 1/2, and we get 1 whole, which makes sense, right? 50 cents for a half a pound. If you double it, it'll be $1 for 1 pound. And compared to Ed, so Ed is the almighty standard. So when 1 is greater than 75 cents. So for A, we have greater than Ed. For farmer B, 75 cents for 1 pound, that is the unit rate. And that is exactly the same as Ed. So for B, it is equal to Ed, because they're both 75 cents per pound. For C, we need to divide again. We have $1.75 divided by 2.5 pounds. Now I'm converting it to decimals just because that makes it easier for me to calculate with my calculator. I get 70 cents per pound. That is less than Ed, isn't it? 70 cents is less than 75 cents. Finally, for farmer D, it's $5 divided by 8 pounds. And 5 divided by 8 is 625. We're going to round it to 63 because we're dealing with money. And 63 cents is less than 75 cents. So there you have it. Number 1 was all about unit rate. And to find unit rate, you need to divide. This next problem is about writing an equation. So first, you need to find your unit rate because our equation for proportional relationships is y equals kx. And k is the unit rate. Or, because we're dealing with proportional relationships, we call it the constant of proportionality. That's just a big fancy word. Here goes my vacuum. Thank you. That's the big fancy word for unit rate when we're dealing with proportional relationships. So in order to write our equation, we need to know the unit rate. So here, it tells us that Troy, let's see, it takes him an hour and a half to mow, and he charges $30. So we want to know his price per hour. So because we want to know per hour, I need to put the hours in the denominator, right? So it's $30 per hour, so we divide. 30 divided by 1.5 is 20, which means he's charging $20 per 1 hour. That means our equation is going to be y equals 20 times x. But notice they give you certain variables to use. H stands for hours and D stands for dollars. Well, the amount of money that you pay, or the amount of money that Troy is going to charge, depends on the hours, right? It's $20 per hour, so this is where the H goes. And once you multiply it, that tells you how much money he's going to charge, or your dollars. So this is your actual answer. In number 3, we're looking at complex fractions. So we're still trying to find a unit rate, but we're using it with fractions. So Reuben has an empty cup under a leaking faucet. After an hour and a half, he's collected a 1/4 cup of water. So let's use a proportion for this one. An hour and a half, that's 1.5 hours. He gets a 1/4 cup of water. So instead of 1/4, I'm going to put 0.25 cups. What is the rate in cups per hour? So actually, I want this the other way around. Let's rewrite this one. So we're going to have 0.25 cups per 1.5 hours. So I can just divide this to do our unit rate. Or you can make the proportion. It's okay. Either way, we want to know how many cups are in 1 hour. So let me show you why it doesn't matter. We're going to use cross products here. Because remember, cross products are equal. 1.5 times x is equal to 0.25 times 1. And to figure out what number we have to multiply times 1.5 to get that answer, we have to divide. And look, that's what we would have done right here. We're still dividing. So either way, you have to take 0.25, which is your quarter cup, and divide it by an hour and a half, and you get 0.166666666 repeating. So we would round that to 0.17 cups per hour. So for the next one, and personally I thought this was the most challenging of them all. It takes 1.5 minutes for the drawbridge to rise 6/20ths of its total height. How much time in minutes does it take for the drawbridge to reach its total height? So in this case, the total height, that's your denominator. So we're going to make a proportion. It takes 1.5 minutes, so 1.5 minutes to reach 6/20ths of the total height. What we want to know is how many minutes will it take for it to reach 20/20ths. Oops, I'd hit mute, sorry. So to make this easier, let's change our fractions in the denominator to decimals also. So I still have 1.5 minutes. 6/20ths, you can see if you wanted to use your calculator, 6 divided by 20 is 0.3, which makes sense because 6/20ths is equal to 3/10ths, which is 0.3. And now on this side, 20/20ths, well, that's 1 whole. And that's what we're looking for 1 whole, 100% of its height. Cross products, we have 0.3 times x is 0.3x, and 1.5 times 1 is 1.5. In our last step, just like before, we want to divide by 0.3, and 1.5 divided by 0.3 is 5. And if we look back up at our original problem, the x stands for how many minutes? So this means it would take 5 minutes for this drawbridge to reach its total height. This next problem, they want to see if you can read a graph. So this was actually multiple choice, and they really tried to make it confusing. All you have to remember is that unit rate, which is what this was referring to, is y over x. This is your y-axis, so the protein in grams, and then the x-axis is the amount of peanut butter. So they want to know specifically about this point, 6,30. Remember, your points are listed as x and then y. So in this case, the x would be 6, so it's talking about 6 tablespoons of peanut butter. And the 30 is referring to the grams, 30 grams of protein. So the point 6,30 on the graph represents that there's 30 grams of protein in 6 tablespoons of peanut butter. 30 grams of peanut butter, 30 grams of protein, because there's the protein. 30 goes with the y, which is on the y-axis. 30 grams of peanut butter for, oh my gosh, I said it again, 30 grams of protein. 30 grams of protein for 6 tablespoons of peanut butter, because the 6 is here. So this one was just about reading the graph. So just make sure your labels are matching with your x and y axis, and that you know that x goes first and then y, and I think you'll be okay on that one. The commission problem. A salesperson earns commission. So commission is when you're making money off of your sales. So usually people that are in sales, they have a small salary, but most of their money is earned on this commission. So that's why they try really hard to sell you things. So this salesperson earns 5% on the first $5,000, and then 7.5% commission on anything over $5,000. So they're telling you that this one made $8,000 in sales. What is her commission? Well, we know the first $5,000 is going to make her 5%. Remember, 5% is the same as 0.05. Okay, so that's the first $5,000. She went all the way to $8,000. Well, that's an extra $3,000, right? $5,000 plus $3,000, that makes $8,000. Now this extra money, after that first 5,000, she makes 7.5%. 7.5% is 0.075. So all we have to do is, I keep hitting that button, all we have to do is multiply these two amounts and add them together. That'll be our commission. So 5,000 times 5% is $250. Now let's add 3,000, or multiply 3,000 times 7.5%, and we get $225. When you add these together, it'll be your total commission. We have $475. So what you need to recognize is that when you're working with commission, sometimes it's broken up. Sometimes they'll give you a smaller percentage for the first amount of money, in this case $5,000, you get 5%, and then they try to incentivize you. They try to really get you to work harder to make more than that, and they'll give you more money. So in this case, she made $8,000 in sales, so her extra $3,000 earned her money at a 7.5% commission. So you just have to calculate both of those and add them together. So this problem's a little bit different. In this one, they're telling you the total commission, and we have to figure out what our sales were. So again, it's 5% on $5,000. So $5,000 times 5%, which remember is 0.05. And she's going to make 7.5% on whatever she makes over that. We don't know how much she's making, but we do know that these two things added together equals $1,375. So we have to figure out the missing amount, which is this X right here. So let's figure this out. 5,000 times 5%, it's $250. I should have remembered that from the last problem. Plus, I don't know what this is, so we're going to use the variable. 7.5% of some number plus that original $250 gives you $1,375. There's our equation. So let's solve it. Let's get rid of the 250 by subtracting it from both sides. We have 0.075x is equal to 1375 minus 250, which is 1125. And now, remember, we want to divide by that 7.5% on both sides, because that will isolate the variable. So 1125 divided by 7.5% is $15,000, but that is not our answer. Remember that we have to include the original 5,000, because this $15,000, that's the X. Remember, we have to add it to the 5,000 to get our total sales. So 15,000 plus 5,000 is $20,000. That is how much this particular person had in sales. The next problem is a nice break. It's a little bit easier. Here we're just identifying proportional relationships. A proportional relationship has a constant of proportionality, meaning it has the same unit rate every time. So for every coordinate or every pair on the table, when you divide y divided by x, you should get the same number. If you don't, it's not proportional. So let's look at A. In this one, we have 0 divided by 1, which would be 0. Sorry, 0 divided by 1. And then for the next one, we have 3 divided by 2. Well, 3 divided by 2, that's 1.5. These don't make sense. So I know that this first one, oops, why won't that erase? It's not erasing. I don't know. So it can't be A. Let's try B. 1 divided by 1 is 1. 3 divided by 2 is 1.5. Well, that doesn't make any sense. So we now know it can't be B. Let's try C. 2 divided by 1 is 2. You see, I'm just taking y divided by x. 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is 2. All of these work. So I am pretty sure that the answer is C, but just to be sure, let's try the last one. 3 divided by 1 is 3. 5 divided by 2, well, that's 2.5. That's not the same. So we were right. The answer has to be C. It's the only one that has a constant of proportionality. And then, oops, I hit a button. Okay, on this one, we want to write an equation. So first, we need to know our unit rate, our constant of proportionality. So I can see this point, oops, this point is one that I can use. So unit rate is per 1, but when we can't read it, like I can't tell it's going to be here, like that's really hard to read. So you can take another point on the graph, and because it's proportional, it goes through the origin, I can just divide. So let's figure out what our coordinate is. X comma y. Let's see, x is 8. There's my x. Y is going to be 14. There's my coordinate. And because it's proportional, I can take 14 and divide it by 8. Both of these are even, so let's divide them by 2. And we get 7 over 4. Now, that's our unit rate. And remember, our equation is going to be y equals k times x, where k is the unit rate, or constant of proportionality. So for this particular equation, it would be y equals 7 over 4x. Okay, on to the salary problem. Rita gets paid $16 per hour for the first 8 hours, and then she earns time and a half, 1.5 times her hourly rate for any time she works over 8 hours each day. And here's her schedule, 8:15 to 12:45. Then she takes a 45-minute lunch break. So let's figure that out real quick. So 12:45, and if you go 45 minutes later, so think about your clock, right? Here's your 12, here's your 3, 6, 9. Okay, so at 12:45, here's 45 minutes, right? Because this is 15 minutes, 30 minutes, 45 minutes. This is 1 hour if you go around the clock. All right, so we're starting at 12:45. So we're going to start here, and she's taking a 45-minute break. So each quarter is 15 minutes. That's 15, 30 minutes, 45 minutes. That's at 1:30. So she goes back to work at 1:30. And then she works until 6:15. Now let's calculate from 8:15 to 12:45. So the arrow is pointing at the 15 minutes. Okay, so that's 8:15. If we go around once, that's 9:15, 10:15, that's 2 hours. 11:15 is 3 hours. 12:15 is 4 hours. But she gets to 12:45, not 12:15. So it was 4 full hours, and then halfway more because she has to get to the 45, right? Because she went to 12:45. So halfway around is 0.5. So from 8:15 to 12:45 is 4.5 hours. Okay, that's the morning. Then she goes to lunch. We already know that she starts lunch at 1:30. She starts work at 1:30, not lunch. She finished lunch at 1:30, so she's back at work. So from 1:30 to 6:15, well, 1 hour would be 2:30. 3:30 is 2 hours. 4:30 is 3. 5:30 is 4. So at 5:30, she's worked for 4 hours, right? And that's at 5:30. She gets off at 6:15, so that's not a full hour, right? So at 5:30, we have to keep going until we get to 6:15. So from 5:30, which is, we'll say here, this is 15 minutes, 30 minutes, 45 minutes. We're now at 6:15. It's been 45 minutes. Well, 45 minutes is 3/4 of an hour, right? Because we went 3/4 of the way around the clock. So your decimal for 45 minutes is 0.75. So we had the 4 hours that got us to 5:30, and then we had to go 3/4 of the way around again to get to 6:15. If we'd gone a full hour, it would be 6:30, and that's not what she worked. All right, so she worked 4.5 hours in the morning, and then she worked 4 3/4 hours after lunch. So now we can start talking about how much money she made. Well, she makes $16 for the first 8 hours. So let's figure out how many hours she actually worked. 4.5 from her morning shift plus 4 3/4 for the afternoon shift together is 9 hours and another quarter hour. So 9.25 hours is her total. Well, she gets paid for the first 8 hours one amount and then the rest of it another amount. So let's take this 9.25 hours and let's take out the first 8 hours. Because she gets paid her regular rate there. Well, how much is left? Well, if you take 8 hours away from 9.25 hours, you're left with 1.25 hours or 1.25 hours. So this is perfect, right? The first 8 hours, she makes $16 an hour. So we're going to multiply to figure out how much money she made for her regular 8-hour shift. That's $128. So now, time and a half. That means her regular hours, that's 16, plus half more. Well, what's half of 16? It's 8. So we just have to add that together. And we get 24. You could also calculate it 1.5 times her hourly rate. So you could take her hourly rate, which is 16, and multiply it by 1.5. You still get 24. So she has an hour and a quarter of overtime, and that's at $24 per hour. Notice she does not make $24 an hour for the entire shift. She only makes $24 an hour for any time after her first 8 hours. So $1.25 times $24 is $30. So to figure out how much money she worked, or how much money she earned, rather, you just add these together. And 128 plus 30 is $158. Not bad for a Monday. All right, Abby and her oranges. So she squeezes 4 oranges to make 1 cup of orange juice. Okay, so picture it. We have, oh, I don't have orange, I have red. So here's 4 oranges. And together they make 1 cup of orange juice. They want you to write an equation. But look, they want to know how many cups of orange juice, which is y, that you can make by squeezing the 1 orange. So a lot of people thought that the unit rate here, we're still using our formula of y equals kx. Remember, they're telling you that x represents the number of oranges. So 1 orange doesn't give you 4 cups of juice. 1 orange only gives you 1/4 a cup of juice. That's your unit rate. So instead of saying 4 oranges per 1 cup, which is true, this time they want to know what it would be per orange. So 1 cup divided by 4 is 0.25 or 1/4. So your formula here is y equals 1/4 x. Or you could have written y equals 0.25x. Because they want to know how much you get per orange. And every 1 orange only gives you 1/4 of that cup. 4 oranges is what you need to make 1 whole cup. So that was the tricky part for this one, is that because x was oranges, the unit rate was based on the orange. And it takes 4 oranges to make a full cup, so your unit rate for every 1 orange, you only get 1/4 cup of juice. So we know that it takes 4 oranges to make 1 cup, right? 1 orange only makes 1/4 cup. That was our unit rate. So we need to figure out the missing pieces, and we can use proportions to do that. So if we have 4 oranges per every 1 cup, we can say, because I'm going to use this one to figure out A, 5 oranges, notice oranges are in the numerator both times, gives me A cups of juice. So this is the one we're trying to solve. So let's do our cross products. 4 times A, that's 4A. I can use A instead of X, that's okay. Equals 5 times 1, which is 5. And now divide both sides by 4. So A is equal to 5/4, which is the same as 1 and 1/4, which is equal to 1.25. So any of those answers were acceptable because that's what A would be. These are all equivalent expressions. They all represent the same value. All right, so moving on to B, I'm going to use my same original proportion, 4 oranges to 1 cup. And now, we don't know how many oranges. So I'm going to say B number of oranges, there's my variable, for 6 cups of juice. Again, let's use our cross products. Cross products are equal, so they're very handy. So 1 times B is B, and 4 times 6 is 24. Therefore, B is 24. It's 24 oranges for 6 cups of juice. And we said this was 1.25. So that was how you solved number 12. Still with the oranges. So we know that the unit rate, we know that our equation is y equals 1/4 x. Right? Every 1 orange gives you a 1/4 cup of juice. Well, Abby can buy these bags of oranges, and in each bag you have 10 oranges. Okay, so hold that in your head. She needs to make a 1/2 gallon. Well, remember, 1 gallon, and I gave you this little tidbit before the test, was 16 cups. So 1 gallon is the same as 16 cups. She needs to make a 1/2 gallon of orange juice. A 1/2 gallon, well, if 1 gallon is 16 cups, a 1/2 gallon is 8 cups. So let's see, we need to make 8 cups of juice. So we can use our formula. Remember, X was the number of oranges, and Y was the amount of juice. Well, we know the amount of juice that we need 8 cups. So we're going to plug in, or we're going to substitute 8 for the Y, and now we have to figure out what X is. So 1/4 times some number is 8. So to figure that out, we're going to divide both sides by 1/4. So we have to figure out what is 8 divided by 1/4. 8 divided by 1/4, if you remember, we need to multiply by the reciprocal, because this is how we solve complex fractions. And let's see, my denominators are both 1, so that's handy. We just need to multiply 8 times 4, which is 32. So we need 32 oranges to make 8 cups. Because we figured out that X is 32, and X is the number of oranges. Now here was the trick. I didn't really agree with this question. I thought it was a little unnecessarily tricky. It says you need how many bags of 10 oranges? Because it says you can't buy partial bags, which is true. If you go to the store and they're selling bags of oranges, you can't say, well, I only need 8. I'm just going to, open the bag and get rid of 2. No, you wouldn't do that. So you need 32 oranges. They come in bags of 10. How many bags of oranges do you need? Well, 3 oranges wouldn't be enough. I'm sorry, 3 bags wouldn't be enough. 3 bags would only be 30 oranges. We need 32. So the correct answer was 4 bags of oranges. Yes, you would have some left over, but that's okay. They're a healthy snack. You can always have them aside from the juice. So that's why the correct answer was 4. So I hope this review was helpful. If you plan on taking the retake, I hope you have good notes because they're going to be very similar problems to what we just went over. So good luck.